Assalamu alaikum student and welcome to this new lecture of refrigeration air conditioning. Today we are going to discuss compressors, basic classification and design overview. I am Dr. Muhammad Ehtishamul Haq, Assistant Professor, Mechanical Engineering Department. So we are going to discuss different types of compressor and how do they function, their application, etc. So what are the compressors? Compressors are mechanical devices that compress gases. It is widely used in industries and has various applications. How they are different from pumps? A major difference is that compressor handles the gas and pumps handles the liquids. As gases are compressible, the compressor also reduces the volume of gas. Liquids are relatively incompressible, while some can be compressed. So what are its applications? So compressors are used in air conditioners, for car or for home, and that's our main objective here. Home and industrial refrigeration, hydraulic compressor for industrial machines, air compressor for industrial manufacturing. So there are large size of compressors which are used in industry for manufacturing purposes. Types of compressors. There are two basic types of compressors. They are based on their method of working. There's two basic types are positive displacement and dynamic type. In the positive displacement type, a given quantity of air or gas is trapped in a compression chamber and the volume it occupies is mechanically reduced, causing a corresponding rise in the pressure prior to discharge. At constant speed, the airflow remains essentially constant with variation in discharge pressure. So it will take pressure, it will take vapor or gas into a chamber and then compress it and then raise this pressure, reduce its volume, raise its pressure and send it from the other end. So you can see that this is a batch type of operation. It is not a continuous operation. Instead, it is a batch type of operation. So in a positive displacement compressor, always it will be fluctuating flow. It will trap one amount of fluid, compress it, send it, then get a fresh amount and then compress it and send it forward. And dynamic compressor, whereas it's a continuous process. Dynamic compressor impart velocity energy to continuously flowing air or gas by means of impellers rotating at very high speed. The velocity energy is changed into pressure energy both by the impellers and the discharge volutes or the diffuser. In the centrifugal type dynamic compressor, the shape of the impeller blades determine the relationship between the air flow and the pressure or head generation. So there's two things here in the dynamic type of compressor. There is a blade or a van that is continuously rotating, and that's the one which is imparting kinetic energy on the fluid, on the vapor or on the gas. And then there is a volute or a diffuser. The shape of the volute or diffuser is such that it will convert that kinetic energy imparted by the blade or the van to a pressure, to pressure. It will convert that dynamic kinetic energy to pressure. Two basic types of compressor, and the same thing, positive displacement or dynamic. Then positive displacement can be reciprocating and rotary type, and dynamic is the centrifugal and axial type. Further, the compressor types can be further divided as the two basic types remain same, the positive displacement and the dynamic is still the same, centrifugal and the axial. But on the positive displacement side, we have two other classification. We call some of them as rotary, the others as reciprocating. And then the rotary could be due to rotational motion of the lobe, screw, liquid ring, scroll or van. I will show you some of these examples later on. And in the reciprocating type, the single acting is very familiar. This is same like your IC engine type, and piston is moving inside the cylinder. And double acting means basically the piston can compress the fluid or the gas in both directions, moving upward or moving downward, or moving forward and moving backward. It will compress the gas in both directions. Then we call it's a double acting one. And diaphragm one is basically a diaphragm which is compressing the liquid. This one is basically used for a small amount of air or gas when it needs to move. So diaphragm for it's a smaller size. Normally it's a smaller size. Now the compressor type, the 5 most common types are reciprocating, uses a piston cylinder and valves. So intake valve and exhaust valve. Most common type of this is the most common type of compressor, the reciprocating type. That's mostly used in our refrigerator or in air conditioner. Screw type, lobes of 2 rotating screws trap and compress gas. Centrifugal, use centrifugal force to compress gas. Common in large refrigeration systems, 200 to 10,000 kilowatt of refrigeration capacity. Van type of compressor, van uses a roller to compress gas. Used in most domestic refrigeration and AC systems. This is normally for a large AC system we use it. The scroll compressor, 2 interfitting spiral shaped scroll compresses the gas, used in 1 to 15 ton range of AC application. I'll show you an example of this one also. So this is the range of the capacity, the approximate range of cooling capacity covered by various compressor types. So if you know what is the refrigeration capacity you are requiring, then accordingly you can select your compressor, that whether it will be a rolling piston type or a scroll type or rotary vane type or reciprocating type or turbo type or screw type. So based on your required refrigeration capacity, you can select the compressor by this diagram. And this one, compressor pressure ranges. So this side is the vertical axis is the discharge pressure, and the horizontal axis is the inlet capacity. So if you can see, the highest pressure can be generated by the reciprocating type of compressor. Okay, this line here is showing you the reciprocating compressor. So the highest compression can be produced by the reciprocating compressor, and then the second will be the centrifugal type of compressor, and rotary screw type of compressor, sliding vane and lobe. But if you compare the pressure and the intake capacity or intake volume, inlet volume, so you can see that the highest pressure can be received by the reciprocating compressor. But if you need large volume, then you have to go, the largest volume will be offered by the axial type of compressor. So that is the dynamic type, axial type, or the centrifugal type, which is dynamic type. They can give you, because they are the reciprocating or positive displacement type of the compressors are batch type of compressors. So they cannot produce large amount of volume. They can produce the highest pressure, but cannot produce large amount of fluid. Whereas the centrifugal or the axial, they are not as high in the compression pressure, but they can supply you a larger volume. So that's the difference. That's how you select which type of compressor you should be taking for your application. So this is the diagram or a sketch just showing how the reciprocating compressor works. And I will try my best to show you a video also during this lecture, so you can understand how a reciprocating type compressor works. Basically it works the same way as a engine works, a piston cylinder engine works. So reciprocating compressor used for air and refrigerant compression works like a bicycle pump. Cylinder volume reduces while pressure increases with pulsating output. Pulsating, not continuous output, pulsating, as I was saying, it's a batch kind of process. Many configuration available: single acting when using one side of the piston, and double acting when using both sides of the piston. So see, this is the intake valve and this is the exhaust valve, and this is the piston which is continuously moving back and forth into the inside the cylinder. Suction line and the discharge line. So one side will take the refrigerant or the vapor in, and after compressing it, the other side will let it out. This is the same reciprocating compressor. Okay, if you remember, it looks like similar to piston cylinder arrangement in case of an engine. So it is a positive displacement compressor that uses piston driven by crankshaft to deliver gases at high pressure. So it has an intake valve here and the exhaust valve here, an intake valve and the exhaust valve. So when as the piston is moving down, then the intake is open and fresh amount of refrigerant vapor or the gas is entering into it. It reaches its bottom right center, and then when it starts moving, so the intake valve will close, and after it has compressed the gas, the exhaust valve will open. This exhaust valve will open after the gas has been compressed. The exhaust valve will open then. The intake gas enters the suction manifold, then flows into the compression cylinder. So intake valve will open and the gas will flow into the cylinder. It gets compressed by piston driven in a reciprocating motion via a crankshaft. So the crankshaft will push it up and compress it, discharge at higher pressure. So when the pressure is raised, the discharge port will open, exhaust valve will open, and it will take the compressed air or compressed refrigerant will leave from this side. So that's how a reciprocating compressor works. This is another positive displacement compressor, rotary compressor, rotors instead of piston, continuous discharge. So in this one, the discharge is continuous. So it traps one small volume here and then rotates it, takes it to the end, and it's compressed, and then it goes out from there, entering from here, and as it is rotating, the gas is being compressed, and then it will go out from the other end. It's 30 to 200 HP power. It could be lobe, screw compressor, rotary vent, slide vent. So we'll see the other ones as well. This is basically the screw type. Rotary compressors are positive displacement compressors. They are commonly used to replace piston compressor where large volumes of high pressure air are needed. So their volume is larger than the reciprocating type. The rotary type gives you a larger volume, but even then it will not be as large as the dynamic type, either for large industrial application or to operate high power air tools such as jackhammers and etc. Rotary screw compressors use two meshing helical screws known as rotors to compress the gas. Gas enters at the suction side and moves through the thread as the screw rotates. The meshing rotors force the gas through the compressor, and the gas exits at the end of the screws. So this is also the example of a screw type of compressor. So suction side from here, this gas is trapped here and it will be moving in this direction, and discharge end on the other side. When it is discharging, the volume has been greatly reduced. This is the figure which is showing the cutout, how these two screws looks like inside the compressor. The air passes through the intake opening into the rotors that are open on the suction side. As the screw rotates, the air intake opening closes, the volume in the chamber is reduced and the pressure is increased. Compression is completed, final pressure is reached, and discharge starts. So this is the example of the screw compressor, as you can see on your screen. That from inlet, the gas is coming in and it gets trapped between the two helical screws, and its volume is being reduced, pressure is being raised, and it's discharged from the other end. Okay. So that's why, because this is also, it is a continuous type of process. so it gives you larger volume. It is not even as continuous as you will see in the dynamic compressor, centrifugal type compressor or the axial type compressor, but it is very close to it. Okay, so moving on, this is the dynamic compressor, the centrifugal type of compressor. So these are the impeller, and this is the diffuser plate here. But this is the impeller, this is the blade which is rotating at very high speed. The shaft rotates at around 3000 rpm, so it's rotating very fast, and this is imparting the kinetic energy to the gas or the vapor which is coming in through the eye, and it comes this way through the eye of the rotor, and then it goes into the blade, and it will impart the kinetic energy onto it, and then it will go to the diffuser, and in the diffuser this kinetic energy will be changed to the pressure. So centrifugal compressor, rotating impeller transfers energy to move air, continuous duty, so it has, because it is continuous duty, so it gives you a larger volume and continuous supply of air or the fluid. Fluid flows, enters the impeller axially and discharge radially, so it's coming axially from this direction, okay, and then it is coming axially from here in the axial direction, and then it will go out radially in the radial direction. This way it will come out. So high volume applications, 12,000 CFM it can give you. So it's a larger volume as compared to any positive displacement compressor. So this is a process how it works in centrifugal compressor. Okay, it is a dynamic high-speed compressor which depends on transfer of energy from rotating impeller to the air. The rotating impeller is this blade here. The rotating impeller is this. This is the impeller. This is the impeller. This plate is the impeller, which is rotating and continuously imparting kinetic energy to the air. And air is coming from the eye, right from here. The air is entering right from here. This is where the air is entering. This is where the air is coming in, and then the rotating blade will impart kinetic energy to it, and this is the diffuser. Okay, in this case this is actually a figure for a pump, not for a compressor, but the function is about the same. Okay, they achieve a pressure rise by adding kinetic energy velocity to a continuous flow of the fluid through the rotor or the impeller. This kinetic energy is then converted to increase in potential energy static pressure by slowing the flow through a diffuser. So this flow, because it finds a larger area, it is high velocity, kinetic energy is being imparted to the air or to the gas. So, and then all of a sudden it finds a larger area, so it slows down. When it slows down, its kinetic energy converts to the potential energy, which is the pressure. Okay, potential energy is static pressure. So static pressure will rise and it will be supplied. The gas or air will be supplied. These types of compressors are also designed for higher capacity because flow through the compressor is continuous. It is not as opposed to batch type process, which is the positive displacement. This one is a continuous process. Impeller transmit energy to energy, the volute, transmit energy which is converted to pressure. So this is the actual type of compressor, flow compressor, which is normally used in the aircraft. So working fluid principally flows through parallel to the axis of rotation. Okay, the working fluid is coming from this direction, from here. The working fluid will be coming from this direction. Let's see, it is coming from like this direction. This is how the working fluid is getting in this direction, and it is being compressed. This is, these blades, they are compressing the air and it will be discharged from the other end. Okay, so the working fluid principally flows parallel to the axis of rotation the energy level of the air or the gas flowing through it is increased by the action of the rotor blades, which exert a torque on the fluid, have the benefit of high efficiency and large mass flow rate, require several rows of airfoils to achieve large pressure rise, making them complex and expensive. Okay, now after this we come to our specific application of compressor to the refrigerator. Before I discuss that, I want to show you back the graph because we have seen that now this will make more sense to you, because this is the reciprocating type compressor. You see it has the largest pressure, but if you look at the volume, then the largest volume is given by either the centrifugal pump or the axial one. Axial one gives the most. So that's the axial one that you looked at. That's the axial one that you looked at. This is the one. Okay. So moving out the hermetic compressor or semi-hermetic compressor. Hermetic compressor is what we used in the refrigerator or in the air conditioner, mostly in your houses or for domestic application. The hermetic or sealed compressor is one in which both compressor and the motor are confined in a single outer welded steel shell. So the motor and the compressor both are inside this shell. The cutout is there. So here it is the compressor and the motor is this one. The compressor is here, somewhere here, and the positive displacement reciprocating compressor is here, and the motor is the down one. This is the stator, maybe this is the stator of that motor. Okay, the motor and the compressor are directly coupled on the shaft, on the same shaft, with the motor inside the refrigeration circuit. Thus the need for a shaft seal with the consequent refrigerant leakage problem was eliminated. So main reason of making it this one, to avoid the leakage of the refrigerant, because if the motor is separate and the compressor is separate, then there has to be a shaft which is going from motor to the compressor. So you have to seal that shaft. So no matter how good sealing you do, after some time it will start leaking. So that can leak your refrigerant also. So hermetic compressors are ideal for a small refrigeration system where continuous maintenance or replenishing refrigerant and oil charge etc. cannot be ensured. Hence they are widely used in domestic refrigerators, room air conditioners. So the lubricant which is required by the moving parts of the compressor are also inside this compressor. Where you see this winding here, the lubricant is basically also at the same place here, which is lubricating the compressor moving parts, piston and cylinder and other moving parts in the compressor. Mainly piston and cylinder, it is lubricating that, and at the same time it is providing some cooling to the motor also, which is dissipating heat. Okay. Semi-hermetic, since the complete system is kept in a welded steel shell, the hermetic compressor are not meant for servicing. A variation of the hermetic compressor is a semi-hermetic compressor in which the bolted construction offers limited serviceability. So this one you cannot service because this is all sealed. This is welded together. Two parts are welded together. The bottom part and the top part are welded together. So it cannot be serviced. Once your compressor is gone bad or your motor is gone bad, you have to throw away your entire compressor and put a new one in there. But to avoid that, we have semi-hermetic one where this upper portion is bolted down with the bottom portion, so that it can be repaired. It can be, some repair work can be done on it. So this is the top part and this is the bottom part. Okay. So in hermetic type, these two right now they are welded, but in case of hermetic, they can be bolted here. And after that, we have one which is called open type, where the motor is separate and the compressor is separate. So in this one you can service both of them, but then the leakage problem will be there. As the shaft is passing from here, you have to provide sealing here, and that sealing after some time can go wear out, and as a result some lubricant can come out and some refrigerant can come out. So those are the drawbacks. The rotating shaft of the compressor extends through a seal in the crankcase for an external drive, normally used in medium to large capacity refrigeration system for all refrigerants. Note, for system in which the ammonia is the refrigerant, only open type compressor are used. So this is the vent type of compressor. In vent type, these are the vents. These are the vents. There's two parts here to see. This is the one part, we call it shaft, and the other one is the cylinder. So let me show you. This is this inside it, which has van attached to it. This one here. This one here is the. This one here is the rotor. It's a shaft which is rotating, and the outside one, this one, is the cylinder. So both cylinder and the shaft, they are eccentric. They are not centrally joined. Because of that, because there's an eccentric, so there is a gap between the two, between the shaft and the cylinder. In this gap is where the fluid will be trapped, and these are the vans, the black ones. This is the van. This van can move in and out. This van can move in this one towards the center and can move out. So as it is moving, this is the inlet. So when the van comes here and it finds room here, so it will extend out, and the gas which is coming in here will be trapped. So it will trap this amount of gas. The red line, the red portion here is the gas. The red portion here is the gas. So it has trapped this gas, and it will be compressing it. As you can see, its volume is reducing up to here. It will be reduced, and then this is the outlet. So up to here, and it will go out from this end. Okay. So moving on. This is the same process that I have just explained. It's explained here in text. This is the scroll type compressor. Scroll type compressor has basically two scrolls in it. One is the stationary scroll, and other one is the moving scroll. So suction comes here, and the moving scroll will be compressing it, and then it will go from the other end. I'll try to show you a video on that, and you can see how it works. So that's about all the compressor. Okay, that's all the compressor that I want to tell you about, and next time we will do a volumetric efficiency derivation for the reciprocating compressor and do some numerical. Thank you very much. If you have, so I can answer you in your live session. I thank you again.